Oh yes, welcome guys, welcome to this session, and this time around we are doing database management systems, and here is this is a coursework that was given by lecturer. Yeah, and we have a case scenario here. Look, Victoria University Hospital, seeks to enhance its operational efficiency and fulfill its corporate social responsibility by transitioning its patient registration process from a paper-based system to a robust database-driven system. Here, this means that the operation of the clinic have been manual or paper-based. Therefore, they plan to change the system to a data-driven system. So one of the students came up with this diagram just to showcase how the database will look like or will have to operate. And this diagram was drawn in Chinese foot notation. That's one of the notations that we use to draw entity relationship diagrams. And here is an entity relationship diagram. Therefore, I'll have to go through to explain to you a little about this diagram. With the crossfit diagram, we include the tables and their corresponding attributes. Then, on these attributes, we have some which are primary, which are unique identifiers, aka primary keys. And these connectors, they look like a crow's foot. Just like, a crow. A crow, it's a bird. And then the nature of that foot. That's why it is called crow's foot notation, because the connectors look like a crow's foot. And through these connectors that relationships are invoked. And according to this diagram, patient data has a relationship with epidemiological data. It has indirect relationships with different entities like the visitor records, malaria cases. So there are many, and the one you're seeing in yellow, these are virtual entities. These are virtual, weak entities. Therefore, from the recorded diagram, we are supposed to answer part 6. That is redrawing the diagram using Chinese database notation. Yes, chains. And in this process, we have to include relationships, we have to include entities, we have to include cardinalities and attributes corresponding to a single entity. And there are so many ways we can draw this diagram using so many software, but my preference went to draw.io. So let me take that step and we start. And this is the diagram I drew. Yes, this is the diagram. This is the other entity relationship diagram in Chinese foot now. And let me take you through a brief description of whatever you're seeing here. Any entity in Chinese foot is included in a rectangular shape. We represent it using a rectangular shape. And this shape, this entity comes with its corresponding attributes, and represent attributes in Chinese foot using oval shapes. Then, a relationship between two different entities in Chinese foot, it is represented using this diamond shape. Though I gave them colors just to make the diagram distinguished. And these numbers and letters you're seeing, these are called cardinalities between two different entities. For example, let me say an outcome can belong to many epidemiological data. So a single outcome can involve many epidemiological data. So that is what we call cardinalities. So in ER diagrams, our relationships can be many to one relationship, or one to many relationship, one to one relationship, or many to many relationship. So this is what I'm showcasing here. This is a one to many relationship between treatment outcomes and epidemiological data. Let's check the diagram and see. Treatment outcomes and epidemiological data here. So it is a single treatment outcome relating to many epidemiological data. If you look at this connector right here, yeah, and among the attributes, we have those attributes that represent a unique identifier, that is a primary key, and we represent such a primary key in Chinese food by underlining it. Yeah, so wherever you're seeing, whatever attribute you're seeing that is underlined, that is representing a primary key. And these ones you're seeing in green, these are virtual tables. Yeah, they have their attributes, but they are virtual and they are weak. That's why we are presenting them using dotted lines, a dotted rectangle and a dotted connector. Yes. Well, I'll take you through. I'll give you a simple demonstration how you can come up with two entities having a single relationship, cardinalities, and their corresponding attributes. Yes. So let's assume I have this entity. This is patient data, and I have another entity that is health facility, and this health facility has an attribute called facility ID and facility name, and patient data. We have a patient ID, and we also have the patient name. Yes, patient name. Therefore, I need to connect. You need to tap until you see this green stuff coming. Then you connect. Then you also connect here. So these are two different entities, and I filled the color. This apply. Click on it, then you go select the color, apply. Therefore, in between the two entities, there is a relationship. Let me say patients can access a single facility, and I gave this yellow. Therefore, a single patient can access, many patients can access this health facility. And the health facility we're talking about is the Victoria Hospital. And then the patient, we're talking about the students, anyone outside the school. That means if many patients can access a single facility, that means the relationship between the two is a many to one relationship. Many to one. These are cardinality, this is a relationship, this is an entity, and these are attributes. Yeah. So you go on connecting patient data, maybe to training, to visit records, health facility, the related what entity. And then the weak entities, you include them. That's all about the what? the Chinese food, and the shapes are right here. Or you can come down here, then you enable the entity relationship. They are right here, the shapes. And yes, then we go to part, that is part 8. So according to the tables we have right here, we are supposed to generate SQL codes that can help us come up with these tables, their corresponding attributes, and the primary keys. Therefore, I'll take you straight to my SQL workbench, and here is the script. This is how I created the tables. But before I start that, I want to create another database, but I'll show you how to create a database, because before you come up with the tables, you have to first create a database where those specific tables will be situated. So we say create database, then you give the database name, that is VU malaria system, let me say. You terminate, then you run. When you run, yes, you run. Then after you say use this database, which is VU malaria system, to create. Yes, to create. Control copy. To create these tables. So when you look at epidemiological data, this table, this one has data ID, which is a primary key, and you write create table, epidemiological data, open brackets, data ID, and we have to declare it as a primary key right down here. Yeah. So after creating such a table, let's try calling it. For example, using the database I created previously, VU malaria management system. I'm calling it so that I select the table I've created, which is EP. Yes. Then I call the table, and here is our table. Yes, one of the tables, it's right here. Come select the database, then the table. We have the columns, which indicates the data ID, the location ID, recorded data, cases. And well, you can as well show all tables. We can show all the tables. Show tables. Then below are the tables. That is epidemiological data, facility type, geographical location. So every table is right here. And if you want to see yes, a single table or structure of a single table, we can say describe, then a table. Let me say epidemiological data itself. Then I want to describe. That means it has data ID, which is an int, and it's a primary key. Location ID, which is